Welcome to my presentation. My project is about deep learning in residential waste classification. My name is Golois Mouelet. You can also call me Golois. Problem, problem statement. The World Bank predicts 3.4 billion tons of garbage by 2050. Right now, we have government agencies, businesses, and local communities that are spending time, money, and resources to kind of help solve this global problem. There are many, there are growing solutions at the commercial level. We have systems that are being created to improve the productivity of the waste management companies to classify some of those different types of waste, such as paper, plastic, cardboard, and some of those categories. But the approach that I want to take it's slightly different. I want to focus on household, basically giving a picture with a mobile device. Can I predict whether this item is recyclable or not? On the data set, I got my data set from Kaggle, where I had 25,000 images that were categorized into two: organic, just trash, and recyclable and recycle. And then I had to split the data. 80% of my data was for training, 10% validation, and 10% testing. For pre-processing, I did a lot of data augmentations, as you can see on your right as well. I able to flip and rotate images so that my model will not only train for specific angles. So this is a way to improve accuracy as well, as I learned in the class. Uh, I I cropped the images and resized them. I did an experiment with and without cropping and resizing. I didn't see much of a boost in accuracy. So for methodology, I went with transfer learning, where I kind of did an experiment on three pre-trained models: ResNet 50, EfficientNet B0, and ModelNet V2. So then with the data sets, with the split, the training and testing and validation, I went through these models. I added dropout, modify a little bit the light layers. I added dropouts and as well as the dense layers, because I'm only predicting between two values, recyclable or not recyclable. For optimization, I quantize the model by reducing the size using the 8-bit integer quantization. Because of the limitation of the Google Machine Learning Kit, which I'm going to talk about a few minutes, I was kind of I had to use either a float 16 or the 8-bit integer. And at the end, I was able to create a mobile application, Android mobile application, where when I embedded the quantized model using Google Machine Learning Kit, which is a toolkit that allows machine learning developers to embed and to transfer to carry over their expertise into the mobile development field. So my experiment, I have a nice summary here. So the ResNet accuracy was 90%, which was okay. I was like, okay. But it took close to 2 hours to train the model, which is a longer time compared to the rest of the model. The testing time was also um, almost twice, more than twice some of the model. At the model side, that's where some of the issues came to. The model size was 91 megabytes. After quantization, it is 24 megabytes. I didn't feel comfortable embedding a 24 megabytes into a mobile device that, the app itself was less than a megabyte. When we compare ResNet with EfficientNet, EfficientNet B0, the accuracy start dropping. Not sure what happened there, but even though the training time is faster, it took me just less than an hour to train it. The testing time was also quick. The model size, we could see a reduction. I was impressed by the 8-bit quantization, where it's kind of reducing the base model by 3. So here I went from 12, sorry, for 13 megabytes all the way to 4 megabyte in size. The trainable parameters, they were not much compared to ResNet. And as we can see, the best model here is the MobileNet V2, where the accuracy was 93.5. For a base, first release model. I think I was kind of quite happy. I was expecting at least a 95, but I would take a 93. It took also less than 45 minutes to train. The testing time with the 10% of the data set was 25 seconds. The initial model size of the model was 8 megabytes, and after quantization, it went to 2. Basically, this is a 4-time reduction, as you can see here, compared to the rest, which had about 3-time reduction. So with this best model, I was now able to say, okay, I'm going to take my model, my MobileNet version 2 model and embed that into my mobile application. So this is my waste classifier application. I am going to open it up. As you can see, I allow the user to either take a picture if you already have an existing picture, or sorry, either take a picture with your camera, or you can select from the gallery. Let's select from the gallery. So let's say select from the gallery. I'm just gonna select this trash right here and see. So this is some banana peels. So that gave us at the top. I have the label here. So this is trash. Basically, this is not recyclable. The accuracy here is pretty good. I was kind of impressed by that. Then let's pick something else. Let's use the camera. Let's take picture. Here I have just a bunch of plastic water bottles. Let's see how it does in a bunch of objects compiled together. Let's see. Wow, I'm surprised that it gave us a 99% accuracy. Let's see. Let's go with a. Let's see. Take another picture. All right, and see. Given the fact that we have a background here, hopefully the model is able to distinguish the right object. Okay. Recyclable, 79%, which is great. So thank you so much. I definitely learned a lot from the project, and hopefully that's a project that I will continue even after the class. All right. Thank you.